All right, so in our very last section of the year, we will be looking at combinations. So in our last section, we looked at permutations. Permutations, if you remember, were when the order of the arrangement mattered. So for example, if I put all of your names in a hat and I pick 3 names and the first person gets $100, the second person gets $50, and the third person gets $1. That would be a permutation. The order in which you're selected matters because you would get a different amount of money. In today's lesson, we're looking at combinations. Combinations are similar to permutations, however, these are an unordered arrangement of items. So my example for this would be, again, putting all of your names in a hat, but the first person I pick gets 5 bonus points, the second person I pick gets 5 bonus points, and the third person I pick gets 5 bonus points. So it wouldn't matter if you were picked first or third, you would get the same thing. Therefore, it was an unordered arrangement. The items that are selected come from the same group, and no item is used more than once. Again, the order of the items makes no difference. And you'll notice that the formula we're going to see today is very similar to the permutations formula. It's just a little bit longer. R are still the number of items that we're choosing. N is still the total number of items. And this is our combination formula that we're looking at. So it's really similar to the permutation formula. The only difference is that it does have this R factorial in the denominator, which will actually make the number of options less because we're going to be dividing by that. On your calculator, it is the same location as the last time. So if we were doing 10C3, we would press 10 first, pressing the math button over to probability, and then you'll just choose the one right below, which is for combinations. 10C3 is 120, for example. All right, the first 2 examples I'm going to show using the formula, and then of course we can check them with the calculator. So in this one, we have 7C3, which means that N is 7, R is 3. So we'll plug those into the formula. 7 factorial over 3 factorial times the quantity 7 minus 3 factorial. Go ahead and perform that parenthesis subtraction, and we'll get 7 factorial over 3 factorial, 4 factorial. Now, if you wanted to type this all in your calculator, you'd have to put parentheses around it. So I usually just do the top and then the bottom separately. So 7, math over to probability, and choose option 4. So 7 factorial is 5,040. And then we'll do 3 factorial times 4 factorial, which gets us 144. And then lastly, we will divide those. And we should get 35. Now again, let's check that with our calculator using the combination button. So let's press our 7 first, press math over to probability, option 3, and 7C3, 35. So again, on your mini quiz, I won't know if you're using the formula or doing it by hand, but on your homework, when the directions say use the formula, I would like you to use the formula. If you want to try the next one on your own, go ahead and pause the video. If you want to keep watching, go ahead and stay. We can see in this case, N is 10, R is 4. So plugging those into our formula, we get 10 factorial over 4 factorial times 10 minus 4 factorial, which would be 6 factorial. Perform the top, we'll get this number. Perform the bottom, we'll get this number. And lastly, divide them to get 210. Remember the shortcut on the graphing calculator too? You can press second enter to recall what you typed last, and then you can just go type over. So the 7, make it into a 10, and that 3, make it into a 4. We should get 210, which is the same answer. Perfect. All right, now for the rest of them, we don't actually need to use the formula. We can just use the calculator. The hardest part on your mini quiz is going to be determining whether to choose a permutation or a combination. And then your calculator does the work for you. So remember that a permutation, the order matters, and a combination, order does not matter. So in this case, we have 52 cards in a deck of cards. In poker, you are dealt 5 cards to each player where the order of the cards doesn't matter. So it's telling you that. How many different 5-card poker hands are possible? So this would be a combination because the order does not matter. So 52 is our total N, 5 would be our R, and we said it's a combination, so we're doing 52C5. And go straight to our calculator. Pressing 52 first. Oops. And then our math button, all the way over probability, option 3 for combination, and we should get this number. So 2,598,960 ways to deal 5-card poker hand. Okay. The next one, how many different 4-card hands can be dealt from a deck of 16 different cards? Again, the order would not matter because the 4 cards you can rearrange in your hand because once they're dealt to you, you have all 4 and you can rearrange them however you like. So again, 16 is our N, R is our 4. So we're doing 16C4. Using our calculator, we should get 1,820 different hands. All right, on the next example, we have evaluate each. You're going to see multiplication, addition, subtraction with these things. You're really just going to use your calculator to do each one separately. So I would do the top part first in my calculator. And to shortcut, I'm just going to press second enter and go change this. So 7 C4 gets me 35. And then I'll press second enter again. Go back and change this to 6 C3, and I'll get 20. And then last but not least, I can divide those, which gets me 1.75. Sometimes on the mini quiz, they may have it in fraction form. Remember your graphing calculator, if you press math, fraction, it'll convert it back to a fraction. 7/4 is the same thing as 1.75. In this next one, we have 2 combinations in the top. So it is understood an imaginary multiplication symbol here. You do need to do each of these first. You could do them together if you wanted to. I did them separately. So I did 5C3 in my calculator and I got 10. I did 6C2 in my calculator and I got 15. And then I did 11C5 in my calculator and got 462. I then chose to multiply those together to get my 150 over 462. And again, I should reducing this fraction by hand, but usually the answers on the mini quiz will not be decimals, they'll be fractions. So you just need to convert this back to a fraction pressing the math button. And we should get 25/77. You could also reduce it by hand by dividing by a common factor, which was 6. Just make sure in the homework that you are following the order of operations using, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, and then addition, subtraction. All right, on the mini quiz, there will be several questions like this. It will say, determine whether the following scenario represents a permutation. Remember, a permutation means that the order matters, meaning the first person gets something different than the second person. Or is it a combination which occurs when the order doesn't matter? Right, P or C to represent. So we don't have to actually solve these, we're just writing P or C. How many different 4-card hands can be dealt from a 52-card deck? So again, if you're dealing 4-card hands, I give 1 card here, 1 card here. Then I give another card here, another card here, another card. Within here, it doesn't matter which order they got the cards. You're going to pick up all 4 of those together. And once they're in your hand, you can rearrange them however you want. So the order would not matter, making this a combination. The next one, how many different ways can a director select 20 male actors to cast the roles of Mark, Roger, Angel and Collins in the musical Rent. So you have 20 total actors. Only one of them is going to be cast as Mark. The second person will be cast as Roger. So these are different roles, meaning they would get different parts in the play. So the order would matter for this. So this is a permutation. Example C. How many different ways can a director select 4 actors from a group of 20 to attend a workshop? So the first person that the director picks goes to the workshop. Second person goes to the workshop. Third person goes to the workshop. They don't get anything different, whereas in the last one, they got different parts in the play. In this case, the order doesn't matter because they're getting the same thing. All 4 of them go to a workshop, so a combination. And then our last one, 50 people purchase raffle tickets. 3 winning tickets are selected. The first prize is 1,000. Second is 500. Third is 100. So notice that the prizes are different for each way that you're selected. So the order in which you're selected matters. You want to be picked first so that you get the most money. So that would be a permutation. All right, and then the closure, if you're ready to try these on your own, go ahead and pause my video and then press play when you're ready to see the answers. Otherwise, if you'd like to see me go over a few more, keep and stay tuned. So closure says determine whether the problem represents a permutation or a combination, then solve. You may use your calculator. So of the 12 books possible, you plan to take 4 with you on vacation. How many different collections of 4 books can you take? So we have 12 books, we're picking 4 of them, all 4 of them are going on vacation. So does the order matter? No. When we pick the 4 books, we're taking all those in our suitcase, so it doesn't matter which order we pick them, they're all 4 are coming. The first book doesn't get anything different than the 4th book we pick. So we'll have 12 C4 because the order does not matter. C4 gets me 495. The last one, in a race. Okay, before I go any further, if you're racing somebody, you're trying to win. You're trying to beat them to the finish line. So if you see the word race, it is a permutation. You really don't even have to read any further, but in a race, 6 automobiles are entered. There are no ties. In how many ways can the first 4 finishers come in? So N is 6, R is 4, but this is a permutation because, again, racing means the order in which you finish, you either win or come in second place. And then we can type that into our calculator. 6 over to the math, probability. This time we're going to choose the permutation key. Oops. And 6b4 gets me 360. All right, the homework is 11.3. You'll notice, though, that the mini quiz is 11.2 and 11.3. So it covers permutations and combinations. So make sure that you're prepared for that.